All right. Today we are going to work on law of sines and law of cosines to find missing sides or angles in triangles. And unlike the other trig questions, when you use the law of sines or cosines, it can be for any triangle. It does not have to be a right triangle. So just in general, I'm going to give you a formula, and you don't have to write all of these out, but for the law of sines, here I have my triangle ABC. The sine of angle A over side A is in proportion to the sine of B over side B, which is also in proportion to the sine of angle C over side C. Now, when you actually set up a problem with one of these, you only need two. You don't need all three, so we'll solve them like a proportion, and we're going to work on how to find a side or how to find an angle, both today. Before we get into any examples, here is the proof of how they developed the law of sines. So I have a triangle here, and then I have the height dropped at a right angle. And so they're going to write two different little trig functions based on what we've been talking about the last couple of days. And remember, if I have a right angle here, that forces the angle right next to it on a straight line to also be a right angle because they have to add up to 180 to make that straight line there. So I have two little right triangles within this diagram. So if I look at, just going to shade that one in. If I look at angle A here, the side opposite would be the height of that overall triangle, and the hypotenuse of just that little yellow triangle would be B. So we could find the sine of A with that setup. Now, if I come over here, look at angle B, they did the sine again. So sine of B, the opposite of angle B would be where the H is at, and the hypotenuse of that triangle I don't have shaded in would be A, so they set that up. Okay, so now all I'm doing on both sides here in this proof is multiplying both sides by what's in the denominator. So for here, multiplying both sides by B, you get B times sine of A equals the height of the triangle. Same thing over here, multiply both sides by A times sine of B equals that height. Now, because both are equal to the height, what they do in the next step is just set both of those equal to each other. So B sine A sine B, they set those equal. And then all they're doing, divide both sides by A here, it would cancel it out on this side but leave it here. Divide both sides by B on this side, it would cancel it out here, but it would leave it over there, and then that sets up the proportion. Okay, when do you want to use the law of sines? Scooch that up here. When do you want to use the law of sines? You want to use the law of sines if you have two angles. Anytime you have two angles and any side, you want to use the law of sines. The more angles you have in the diagram, the more you want to use the law of sines. So two angles in any side. Or the other situation is if you have two sides given to you and the angle opposite one of those sides, so across the triangle from one of those sides. And we're going to do a couple of them. So some of the questions will have a picture and some won't. I purposely just did questions for us to do together today that don't have a picture to get you guys used to drawing a picture. So this is completely not drawn to scale. I'm just going to draw a triangle. Okay, this is for our reference. So it says the triangle's ABC. So in any order, I'm going to label the angles with capital letters ABC. And if you guys remember, the sides, I'm just going to go ahead and label in this triangle, are across from the angle of the same name. So angle A, side A would be here. Angle C, side C would be here. And angle B, side B would be over here. Now, what do we have in the problem? They give us the angle A is 33 degrees. They give us angle C is 64 degrees, and they give us side A, which is going to be right here, is 8. And then it wants us to find B. Okay, whenever I do law of sines, I like to see what I have. So to set up any of the proportions, you need the angle and the side across from it. So I have angle A and side A. I also have angle C, I have angle C, but I don't have side C. Now, the reason I'm not going to circle that is because the question actually wants us to find side B here. So what I really need is side B with angle B. Now, if you guys remember from geometry, if you have a triangle, the inside angles of a triangle have to add up to 180. So I know two of the angles. So if I just do 180 minus 33 minus 64, the leftover has to be angle B. So they didn't give it to me in the directions, but I have enough information to figure that out. So angle B is going to be 83. Now, I want to use angle B to set up my proportion because I'm trying to find side B. So here's my proportion. I'm going to do sine of 33, sine of A, over the side across from it is 8, has to be equal to or in proportion to sine of B, which is 83, over side B, which is directly across from it, which is what we want to find. All right, so just a proportion, we're going to cross multiply. So I have B times the sine of 33 equals 8 times the sine of 83. And really, this is just a lot of work that you're going to do on the calculator, all right? To get B by itself, I am going to end up dividing by the sine of 33. Now, you do not cancel the signs out or anything like that. The sine of 33 is a number, the sine of 83 is a number. So don't cancel the signs out or anything like that. So here's all I'm going to do. I'm going to do 8 times sine 83. Oops, let's type it correctly. And I'm going to hit equals, and I'm going to divide that by the sine of 33. And we're just going to round to the nearest tenth like it says in the directions here. And so B is going to be 14.6. And that's what I'd be looking for as my answer. Slide this guy up. Okay, so different triangle in example 2. And it says PQR. So again, this triangle is not drawn to scale, it's just a reference for us. And it says side P is 7, that would be across from angle P. Side Q is 10, that would be across from angle Q. And the measure of angle Q is 98. All right, so this is going to fit that description where I said if you had two sides and the angle across from one of the sides. So I can set up one of the fractions in my proportion with that set. Now, I'm actually supposed to find angle R and angle P here. The only other piece of information I have in the drawing is the 7 for side P. So I'm going to match these up. All right, so I'm going to set my proportion up here, and we're just going to find the measure of the missing angle P first. So I have sine 98 over the side across from it, which is 10. That has to be equal to the sine of P over 7. Okay, this is just slightly different than what we just did because we're going to find an angle here. So I'm still going to cross multiply. I would have 7 times the sine of 98 equals 10 times the sine of P. Now, I need to get the sine P by itself. This whole thing, which I could calculate on my calculator, I'm going to write this out just over here a little bit. So the sine of P is going to be equal to 7 times the sine of 98 over 10. I'm going to show you two ways to do this. But ultimately, we're going to end up needing to take the inverse sine of both sides because we need to find an angle measure. Okay, so I can go ahead and do that right from the jump. I can just hit second sine and type this whole thing in, 7 times the sine of 98. Make sure you close the parentheses around that, divided by 10. Or, I'm just going to show you another way to do this. If you want to do 7 times the sine of 98, and then divided by 10, I need to take the inverse sine of that. And I don't want to round it because that would make my answer inaccurate. So I'm just going to show you these buttons here, hopefully on the screen. So I have that answer that I did, right? You can do second sine, and then I want to bring back the answer I just had, so then I can just do second, and then the answer case should be right, the second function above the negative symbol. So ANS, let me pull it back down so you guys can see it. So I did second side, second answer, and that will give me that same value. So you can do that either way. And we're going to go to the nearest degree here, so that's going to be 44 degrees. Now, before I quit and go on to the next question, this is angle P. The question also asks us to find angle R. So then I can just use my geometry because I know the inside angles of a triangle add up to 180. So I know angle Q is 98, angle P is 44. So the leftover, if I subtract that, would make angle R to be 38. Okay. Now, just like the law of sines, the law of cosines can be used for any triangle. It doesn't have to be a right triangle. There is actually 3 different versions of how to write the equation from the triangle. So I'm going to write these real quick just so you guys have all of them, that they all take the same general format. Okay, so these are going to be equal to a side. So side A, and I'm going to square this, is going to be equal to, and the order here doesn't matter, but I'm going to put b squared plus c squared minus 2 times b times c times the cosine of angle A. And I'm going to get into this in a question in a second, but I'm just going to write each of these out for the different possible sides in the triangle. So there's one option. Okay, my next option, let me grab a different color. Let's say I wanted side B. So b squared is a squared plus c squared, the other two sides, minus 2 times the other two sides, times the cosine of the angle across from the side you're trying to find. So they all follow the same pattern. All right, and then finally we can do one for c as well. So c squared is going to be a squared plus b squared minus 2, the other two sides, a times b, and then times the cosine of the angle across from the side you're going to find. So there's 3 different formats that this could appear in. They all take the same format. Whatever side you're trying to find, the other two sides squared and added together, minus 2 times the other two sides, times the cosine of the angle across from the side you are trying to find. Okay, so here, just like I had on the front, is a little proof of how the law of cosines was developed. And again, I have a right triangle here in the inside created by dropping the height on either side of that dotted line. The overall triangle, though, is not a right triangle. Okay, so what they have up here is just a little Pythagorean theorem just for this little triangle here. So b squared, the hypotenuse of that little green triangle, x squared plus h squared, and then also the side x would be, if I had the angle here, the cosine would be adjacent, which would be x, over hypotenuse, which would be b. So they said cosine A times b. What they would do there is you would have cosine A equals x over b. They're taking this little equation here and just putting the b on this side by multiplying. That's where they're developing that. Okay, now, in general, I'm also seeing a Pythagorean theorem for the other triangle, other right triangle that we have in the diagram here, this one. And this entire side across the bottom is called C, so the whole thing. They called this piece of it x, and so the leftover would be the whole side c minus x. So that's where that expression is coming from there. All right, so just doing a little Pythagorean theorem just on this pink triangle. So a squared is the hypotenuse, h squared is one of the legs, and this c minus x squared would be the other leg. All right, now, you don't need to do this or anything, but c minus x squared would cause you to have to do a FOIL. And what's going on is this right here in this expression would be what you would get if you FOILed this out. You get c times c, they get the c squared. Maybe I'll just do it real quick. C times that minus x. We would write in alphabetical order, so it'd be minus cx. Then you would do minus another cx, and then minus turns into a plus x squared. The minus cx gives you that minus 2 that's over here. So that's just already been simplified. Now, what's going on after that? Okay, and I know this is kind of a stretch, but here's what's going on. This 2cx, they are taking the x from up here, and they are putting it right here. That's where that b cosine A came from. So that's just getting substituted in for x. And then they're just kind of manipulating this around a little bit to simplify it, to make it look like what it is that you see up here. But that is the proof of the law of cosines. Now, the law of cosines, when you want to use this, when you have two sides and the angle that's in between them. Okay, so what do I mean by that? So I'm just going to sketch a little triangle here. Let's say I had this was 5, and I don't know, I'm just making something up. This was 12, and I had that this was like 40 degrees. So that would be two sides and the angle between them. Or if you have all three sides. And another thing to remember, you want to use the law of cosines anytime you are given no angles. The more angles you have, you want to use the law of sines. The fewer angles, you want to think about looking at the law of cosines. So two sides and the angle between them, like this. Or if you have all three sides, that's when you want to use the law of cosines. Okay, so let's scooch this up. All right, so it says two stars are 9.5 and 4.6 light years from Earth. When an astronomer observes the stars with the Earth as a vertex, the angle between them is 43 degrees. Okay, so I'm just going to draw a little picture. So we have two stars, and then we have the Earth. So not to scale at all. I'm just drawing a reference triangle here. So it says two stars are 9.5 and 4.6 light years from Earth. That's a distance. So doesn't matter which one. One of them is 9.5 light years away, the other one 4.6 from the Earth. When an astronomer observes the stars with the Earth as the vertex, so I'd be on this part of the triangle, the angle between them is 43. So that would go in between. So this would fall into my category two sides that I know and the angle between. What is the distance between the two stars? So I'll just call that side E because I put it opposite the Earth. Okay, now I'm going to use law of cosines here, and I really like to do this for law of cosines. I kind of call it a side angle side theorem. It's not, it's just my thing, but I have a side and angle in between them and a side. If I have those three in a cluster, then I know that I need to use the law of cosines. Now, to set up the equation that you saw at the top, I know I have different letters here, but whatever the side is across from the angle, that is by itself squared. Now, in any order, it does not matter. These other two sides are going to get used on the other side of the equation. So it's the square of both of the other two sides, and we're going to add those squares together. Minus 2 is part of the formula. And then in any order, the other two sides, so one of them was 9.5, one of them was 4.6, and then the cosine of the angle between them, which for this one is 43 degrees. Now, if you're finding a side, you can literally type this entire thing into the calculator. So I'm just going to grab my calculator here real quick. So I'm doing 9.5 squared. Whoops. Plus 4.6 squared minus. Now, just for my own purposes, I always put this part in parentheses because I'm going to subtract that whole thing. So I just pop up a parenthesis, and I'm just going to literally type out what I have here. 2 times 9.5 times 4.6 times the cosine of 43, and then I'm just going to end that parenthesis because I'm subtracting that whole thing. Okay, now what you have to remember here when you get done typing that in is that is equal to the side squared. So ultimately, I need to take the square root of that whole thing to get my answer. Okay, so two ways to do this. If it's me, if you guys remember from a previous unit, the square root is the same thing as the 1/2 power. So if I'm doing this problem, what I do is I just, right from that step right there, I hit the little caret button here for an exponent. So that'll bring up the word ANS. That means it's going to take my answer I just got. And I just type in 0.5 for 1/2 because that would be a square root. Okay, another way to do that problem real quick, I'm going to type this in again real quick. I've got that 9 squared plus 4.6 squared minus 2 times 9.5 times 4.6 times cosine 43. Okay, if I do that, calculate that again just real quick. I can do, use the square root key, hit second square root, and square root's right above the x squared, and then I just do that second answer like I did on the question on the other side. So I hit second, and then you just hit the little negative key, and that should pop up the word answer back into your calculator. And you can see both of these are the same. And if we're finding a side here, so the distance between these two I labeled with an E, I'd have to put down about 6.9. This would be light years because we're talking about a distance in this question. So two different ways to do that. And one last question here. So this gives me the lengths of the sides of a triangle, all three of them, and then it says find the measure of the angle opposite the longest side. So again, I'm just drawing myself a little reference triangle here. None of these are to scale in any way, shape, or form. So just label one of the sides 10, one of them 14, and one of them 15. Okay. So find the measure of the angle opposite the longest side. So the longest side would be the 15. So the angle opposite that would be the angle right in there. So let me just call that theta. All right, because that's our unknown angle. Now, again, if I'm using law of cosines, I have to use law of cosines here because I don't have any angle measures at all. You want the two sides and the angle between them. That forms that more complicated side of the equation. And the side across from that is going to be by itself on one side of the equal side. So set up here, be 15 squared. And then the complicated side, doesn't matter the order you put these in. So I can put the 10 squared first or the 14 squared first. That doesn't matter. Same thing with this part. You can put the 10 first or the 14 first. It doesn't matter. You're multiplying times the cosine. We're trying to find a missing angle here, so I'm going to put that as theta. Okay, now for this part, law of cosines, if I don't know the angle, I do this in a couple steps. So I'm just going to write out a couple things, and I really want to point something out to you here. So if I square this, this is 225. And then I'm going to do the 10 squared plus the 14 squared. This is going to give me 296. And then I'm going to do 2 times 10 times 14. This is 280 cosine of theta. Now, you have got to pay attention to this for 1 second. Okay, most common mistake people make on these problems, they take what I have written here, this 296, subtract the 280. You cannot do that. The 280 here is attached to that cosine of theta by multiplication. So remember, our order of operations, you got to do the multiplication first. So do not subtract these numbers. Here's what you want to do. You want to actually subtract the 296. And sometimes this will be negative, sometimes it'll be positive, and either way is okay. So I'm just going to do 225 minus 296. And so I'm going to get negative 71, and then I'm going to keep this all together, and it does have a subtraction sign in front of it, so keep that. So the 280 cosine theta. We're going to try to solve for the angle here. Now what I want to do is divide by the negative 280. Okay, now when you do this, these two negatives are going to cancel out, and so I'm going to have 71 over 280 is the cosine of this angle I'm trying to find. I labeled it with theta. Anytime you guys are finding an angle, you remember, you have to do an inverse of the trig function. So all I'm going to do on my calculator is an inverse cosine here. So the cosine and the inverse cancel each other out here, so I just have theta, my angle measure. So I just do second cosine to get the inverse, and then 71 over 280. And we're going to go to the nearest degree. So this is going to be about 75 degrees.